Hello friends, this question is from the subject of network theory from the topic of RLC circuits. In the question, we have a series RLC circuit with a resistance of the value of 10 ohm, inductance of the value of 0.2 Henry and the capacitance of the value of 40 microfarad, and we have a supply with the 100 volt and some frequency f. And the question, it is given that the circuit is in the resonance. Circuit is in the resonance, and we need to find out the upper and lower cutoff frequencies. We need to find out the upper and lower cutoff frequencies of the circuit. So we have a RLC circuit, and we need to find out the upper and lower cutoff frequencies of the circuit. So we know that the bandwidth of an RLC circuit is defined as R by L, which is equal to the R is 10 here and L is 0.2, which is equal to 50. And we also know that bandwidth is nothing but omega 2 minus omega 1 is 50, where omega 2 is the upper cutoff frequency and omega 1 is the lower cutoff. We need to find out the value of omega 2 and omega 1 separately. And with the same formulas, we know that the omega naught is defined as 1 by root LC. My resonance frequency is defined as 1 upon root LC, which is equal to 0.2 into, because L is a 0.2 and C is, so 0.2 multiplied by 40 micro, which is 40 into 10 raised to the power minus 6. So if I can solve this expression, I will get the value at 353.55. We also know that my omega naught square is equal to the omega 1 omega 2. So with the help of equation 1 and equation 2, I may find out the value of omega 1 plus omega 2, which is equal to the omega 2 minus omega 1 whole square plus 4 omega 1 omega 2. It's quite a straightforward mathematics. So I have applied directly. Omega 1 plus omega 2 is equal to under root of omega 2 minus omega 1 whole square plus 4 omega 1 omega 2. I may put the values of omega 2 minus omega 1 is equal to 50 whole square plus 4 into omega 1 omega 2 is omega naught square. Omega naught value we already know, so we can find that's 53.55 whole square, which is equal to the 708.87. So omega 1 plus omega 2 is 708.87. So I can write this equation as equation number 3. So from equation number 1, we know we have omega 2 minus omega 1, so 50. From equation number 3, we have omega 2 plus omega 1 is equal to 708.87. We have two variables, so we can easily find out the value of omega 1 and omega 2. So from solving equation 1 and 3, you can find out the omega 1 as 379.43 and omega 2 as 329.43. The correct option of the question is C. Omega 1 has 379.43 and omega 2 as 329. 0.43. So in this question, if you may see that we have a RLC circuit and we need to find out the omega 1 and omega 2. So we have directly used the network's formula, the bandwidth formula, bar by L. This is a straightforward formula oriented question. So we have applied the formula of bandwidth, which has given as the omega 2 minus omega 1. Then because circuit is in resonance, I can find out the resonance frequency omega naught, which is equal to 1 by root LC. And we also know that omega naught square is equal to omega 1 over 2. Then by the help of these two equations, I can find out the omega 1 plus omega 2, which is nothing but omega 2 minus omega 1 whole square plus 4 omega 1 omega 2. I have put the values and I can get the omega 1 plus omega 2. Now I have two equations. One is omega 2 minus omega 1 is equal and other is omega 2 plus omega 1 or omega 1 plus omega 2. So two equation 2 are known. I can simplify these two equations and I can find out the value of omega 1 and omega 2. So these are the very simple questions but very important because they are very frequent in GATE. Thank you.